Hello, my name is Caleb, and today I will be demonstrating an electrostatic motor. Electrostatic motors can be explained through the basic principle of Coulomb's law. Coulomb's law states that two charges impose equal and opposite forces onto each other. This force is inversely proportional to the square of the distance between the two charges. On the screen here, we see a diagram that shows the electrostatic motor that will be used later on in this video. We see a voltage supply feeding positive and negative charge to two stators on opposite sides of the rotor. These stators will polarize the copper tape that is on the surface of the rotor. With 8 strips of copper tape on the rotor, if left untouched, the rotor will find equilibrium and not move. As you can see here, the forces will balance. But if there is a slight nudge on the rotor, the imbalance of forces will produce an angular momentum that will spin the rotor counterclockwise. After spinning for a couple of seconds, the rotation will eventually reach a steady state and a constant RPM. So now here is the experimental setup for my electrostatic motor demo. I have a power supply which will be feeding a voltage step-up generator, 12 volts. The voltage will be stepped up to around 20,000 volts, which will then be connected to 2 of the stator terminals, which are bent nails. And I have a peanut butter jar with 8 equidistant and equal width copper tape strips. And last but definitely not least, there is 2 magnets underneath the peanut butter jar that is creating the suspension. So as you can see, without any power on, the peanut butter jar will rotate freely. Now let's turn the power on and see what happens. No contact there, and it started spinning, but it did stop. Oh, there it goes. Look at it go. Wow, so it seems I've bumped it just enough that it is getting into a constant rotation. That's amazing. Oh my goodness, look y'all. It's working. I could stare at this all day. Wow. A direct application of Coulomb's law and electrostatic force. Let me try the variable input voltage and see what happens. Folks, I can't lie to you. Before we get to this next part, I just have to sit in admiration.